Now let's discuss a very important part of embedded project, that is the software architecture. So here I have shown you the overall architecture of our embedded software. So first we have the microcontroller, our hardware in the bottom, and on top of that we have our driver. Different drivers we have in our microcontroller, like board driver, timer, ADC driver, PWM driver, like this many drivers are there. On top of driver we have the board support package, BSP. Board support package is nothing but on your board what are all the components are available, and to create abstract for those components we write the board support package. Beside the board support package and driver, see, we have OS, which is operating system. So operating system connected to hardware directly, because it will be directly manipulating some registers into the controller. And on top of this, if you will see, we have our application layer. So application layer is nothing but our functionalities. What are all the different functionalities we want in our project? Suppose if you want to blink a LED, so you will create one .c file to blink a LED. Suppose if you want to run a motor, so you will create another .c file to run a motor, controlling its speed and everything. Suppose if you want to read the data from the sensor and you want to control your motor, so to read the data from the sensor you can create one application file, .c file. This is what the generic structure of any embedded system project. Definitely domain to domain it will vary. Some components will get added, some components will get removed. So in the industry, software architecture is really complex. So here, since we are doing a bare metal embedded programming and we want to keep this project simple, so what I will do is only the needed part I will keep. Driver is the needed part and the application. I will not use the OS and the board support package to keep this project as simple as possible. So if you will see here, I have kept my folder structure also similar to my software architecture. So here we have app. Currently these are the apps. Then we have the BSP. As I said, we are not going to do anything here. Then we have the one build folder. Here all the binaries will be there. So if you will see, all our final executable file is there, map file is there, all the object files are there. There I have kept all the documents. This is compiler user manual, this is GNU Make user manual, this is controller datasheet, controller user manual, and the schematic of board. This is the driver part. I have kept all the driver code here. So clock initialization, port, then address mapping. We will see all these code one by one. We have one RTOS folder also. This is also empty because we are not using it. Apart from this, we have our linker file is here, make file is here, and our startup code is here. So now we will see what are all the different softwares is required for this project. First thing we need is Notepad++. After that, what we need is compiler. Since we are using the STM32F407, which is based on ARM core, we will be using the ARM GNU Cross Compiler. After this, for Make, we will be using the GNU Make. We know we need a flash programmer to flash the code. Flash programmer, we will be using STM32 Cube programmer. So I have already given the link for these softwares. Along with this software, I have given the link for their user manual also. So in case whatever we are going to discuss here, if you want to know further something extra apart from that, because we are going to discuss only a basic level thing, not very advanced level concept or advanced syntax. We are using the STM32F407 blackboard. So we need to know certain details about that board. Those details we will get into the schematic diagram, like which LED is connected to which port, which switch is connected to which port. All these details are present in the schematic diagram. After that, the second document we need is the microcontroller user manual and its datasheet. Since this blackboard is using STM32F407 microcontroller, so we need the user manual and datasheet for this microcontroller. Whatever the theory portion we have covered, we will see one by one, how we implement all of those things practically. Before jumping to the next session, session, let's just have a quick recap what we discussed yesterday. So the first thing is the build flow. So compiler will compile the source file and it will generate assembly instruction. After this, assembler will take the different .s file and will generate the object file. Linker will take your object files and it will take the linker script, and then linker will generate the ELF file, final executable file. Your flash programmer will take the ELF file and it will just flash that ELF file into the flash memory of the microcontroller. So this is the second point what we discussed yesterday, difference between the C programming and embedded C programming. So when you are doing the C programming, at that time memory allocation is taken care by the MMU, memory management unit, and when we are doing the embedded C programming, we are writing the code for a particular microcontroller. At that time memory allocation is done by the linker script, and who writes that linker script? User writes that linker script. Now the third thing we discussed yesterday is C programming memory layout. So whatever the code we are writing, what will go where, that is nothing but the memory layout. X will come here, this constant variable go into the text section, Z will come here, function A will come here, W will come here, P will come here. So all our numerical values will go to the read-only section of the text section. In the memory area, I have given the two memories. One is the flash memory, one is the RAM. All our code and our constant data, that goes to the flash memory. All other data goes to the RAM. All these things are decided by us as a programmer, as a developer. We decide what will go where.